So today we are going to start the class on turbines. Okay. So we are going to start the class on turbines. Have you heard about the turbines? Anyway, have you heard about the turbines? Okay. So what are turbines? Turbines, in a simple term, it is called as power producing machines. Turbines are called as what? Power producing machines. How we are going to produce the power? With the help of kinetic energy of a fluid. With the help of the kinetic energy of a fluid, we are going to convert that kinetic energy to the mechanical energy. Then mechanical energy to the electrical energy. In turbine, what is happening? Only there is a conversion of kinetic energy to the mechanical energy in the form of rotation of shaft. In the form of rotation of shaft. So I will repeat once again. What are turbines? Turbines are the power producing machines where you can produce we are going to convert the kinetic energy of flowing fluid to the mechanical energy. So that is what called as turbines. So depending on the type of fluid we are going to use, there is a classification of turbines. One is water turbines, another is a steam turbine, another is a gas turbine. What are the different classification of turbines? Water turbine, steam turbine and gas turbine. So the name itself indicates if the turbine to produce the mechanical energy, if you are using the water as the main fluid, then it is called as water turbine. So if you are using the steam as a main working fluid, then it is called as steam turbine. So if you are using the gas, that is the hot gases, that what we discussed in the earlier cases. If you are using the hot gases, that will be coming due to the combustion of fuel, fossil fuels. If I am going to use that hot gases to produce the mechanical energy, so then it is called as what? Gas turbines. So for our syllabus, we are going to discuss about the steam turbines as well as water turbines. So we are going to discuss about the steam turbine and water turbines. So today we are going to discuss on steam turbines. So we are going to discuss steam turbine. Okay, so there are two varieties of steam turbines are there. So depending upon the application of force, what kind of force is acting on the blades. So depending upon the type of force acting on the blades, there are further two classifications in the steam turbine. So one is impulse steam turbine. What is the first one? Impulse steam turbine. The second one is reaction turbine. Are you able to understand? There are two varieties or two classification of steam turbine. Based on what? Application of force. What type of force is acting on the blades? So what are two types? Impulse steam turbine, reaction steam turbine. So now we are going to study about the impulse steam turbine. Okay, it is also called as Laval turbine. Okay, it is also called as Laval. So the name is from the inventor. Who has invented this? By name he has given the Laval turbine. So it is also called as what? Impulse steam turbine. So this impulse steam turbine consists of mainly three parts. What are the main three parts it is having is? The first part is nozzle. What kind of nozzle is this? This is the convergent and divergent type of nozzle. What is this? Convergent and divergent type of nozzle. Okay, so this is a nozzle. So there are only three parts are there. So next we have a blades. We have a curved blades. What kind of blades we have? Curved blades, which is mounted on a rotor. Which is mounted on a rotor. So these are the blades which is mounted on a rotor. What is the meaning of rotor? It is a circular wheel. Okay. So this rotor in turn it is mounted on a shaft. So this in turn it is mounted on a shaft. Is it clear? So this is covered with the outermost covering. So this alignment it will be covered, outermost covering. So to protect the devices for the safety purpose. So this nozzle and the blades with rotor is placed inside the case. Our machine parts will also be a so because it will be a rotating part, it will be protected. So with the help of what? Case. Is it clear? So what we are studying? We are trying to study the impulse steam turbine. It mainly consists of how many parts? 3 parts. What is the first one? Nozzle. What kind of nozzle is this? Convergent and divergent type of nozzles. Why it is called as convergent and divergent type of nozzle means, see this is the entry. So from entry point this is called as throat. What is this? Throat. So it is converging. Yes or no? So the cross section of the nozzle is converging. So that's why it is called as, from here to it is called as converging. From throat to the exit, this we are going to call as what? Exit. This is the entry. This is the exit. So the nozzle is diverging. From throat to the exit, it is diverging. Hence it is called as what? Convergent and divergent type of nozzle. Okay. So what is the purpose of this convergent and divergent type of nozzle? So what in this impulse steam turbine, mainly we are converting thermal energy. We are converting the thermal energy to mechanical energy. How this thermal energy is converted to mechanical energy? So the steam will be having the thermal, heat will be there. So that will be converted into what? Kinetic energy. For this thermal energy will be converted into kinetic energy where? In nozzle. So by the expansion of gases, it is going to convert high pressure, low velocity steam. It is going to convert what? High pressure, low velocity steam from boiler. So this steam I am getting from where? Boiler. So where we discussed in the previous classes, that is Babcock and Wilcox boiler. From the boiler, we are getting high pressure, low velocity steam. But to run the turbine, what we need is, we need a high velocity. We need high velocity and low pressure steam. So that's why to convert this high pressure, low velocity steam from the boiler to the high pressure, low pressure, high velocity steam. So we are going to use the convergent and divergent type of nozzle. For the example, so if you are going to water the plants with the help of pipe, right? So pipe will be connected to the tap. To increase the speed, to increase the velocity, what we are going to do? We are going to press the pipe. Yes or no? So what happens? So where we are going to reduce the cross section. So thereby what is happening? So that means we are trying to convert as a nozzle. So that there will be a, what happens? High pressure will be converted into low pressure. And the velocity of the water is going to increase. The same method we are applying over here. Is it clear? So we are getting the high pressure, low velocity steam from the boiler. So I am going to convert that to the low pressure, high velocity with the help of what? Nozzle. What kind of nozzle? Convergent and divergent type of nozzle. Is it clear? So this low pressure, high velocity steam is made to pass over the symmetric blades. What kind of blades is this? Symmetric blades. Okay, so this I have taken one blade and I have written over here. So the steam will be passed over this. The steam will be passed over this. What happens? This low pressure, high velocity steam from where? Nozzle is made to pass over the symmetric blades. It is made to pass over the symmetric blades. What happens here? this steam undergoes change in direction, right? The steam is undergoing a change in direction and also change in velocity. So due to this, there will be a change in momentum. Due to this, there will be a change in momentum. This change in momentum we are going to call as impulsive force. It is going to call as what? Impulsive force. Due to impulsive force, the rotor is going to rotate. The rotor is connected to where? Shaft. So this is the shaft. So the shaft is also going to rotate continuously. Is it clear? So that is about this is the impulsive force. Okay, yeah. So next, this whole body, this whole setup is insert. It is covered in the casing, outermost casing for the safety purpose. So this is what the impulse steam turbine. Okay, I am going to explain you once how to write this in the examination and how to write this in your notes. Okay, please make a note of it. So this is a impulsive steam turbine. It is also called as Laval turbine. Okay. So here it consists. You have to first explain the working. In working, what you are going to explain? It consists of mainly three parts. Which are those? First, you have to explain the nozzle. Next, you have to explain what? Blades. Next, you have to explain what? Casing. So this is about the construction part, not the working. So this is the construction. Okay. So this impulse steam turbine mainly consists of three parts. The first one is nozzle, blade, and casing. What is the explanation for the nozzle? So here the nozzle that they are using is a convergent and divergent type of nozzle, where the cross section is going to converge from entry to the throat and it is going to diverge from throat to the exit. What is the purpose of nozzle? It is going to convert the high pressure, low velocity steam from the boiler to. So we are going to get what kind of steam here? Low pressure, high velocity steam. Okay, na? So that is the explanation for nozzle. Next, what is the explanation of blade? So blade is a curved plates, is a curved metallic plates which is mounted on a rotor. Which is mounted on a rotor. This rotor is mounted on a shaft. That's it. That is the explanation for what? Blades. Is a curved symmetric blades mounted on a rotor, and the rotor in turn is mounted on a shaft. Next one, what is the next one? Casing. So this overall setup is enclosed inside the casing. So for the safety purpose. So this is for the construction. Is it clear? So next what we have to explain? Working. How it is going to work? Working. See what we are going to do. We can explain this working with the help of pressure and velocity graph. With the help of pressure velocity graph. So what kind of pressure we are getting? We are getting the high pressure. Sorry, it's not EP, it is a H. High pressure. Okay. So this high pressure is the end. Okay. So this is I am having a high pressure and low velocity. I am having high pressure, low velocity steam at the entry of the nozzle. So where what happens? So there will be a decrease in pressure. So there will be a decrease in pressure and there will be an increase in velocity. Okay? So there will be a decrease in pressure, increase in velocity. Is it clear? So that will be the entry to where? Blades. So we are going to get low pressure, high velocity steam that will be passed to the plates. What happens in the plates? What happens? So that is the main sentence that you have to write. The low pressure, high velocity steam is made to pass over the plates, where this steam undergoes change in direction and velocity. The steam undergoes change in direction and velocity. So this change in direction velocity results in change in momentum. So there will be a change in momentum. Very important thing. Change in momentum. The force due to change in momentum is called as what? Impulsive force. So this due to this impulsive force, the rotor or the blade is going to rotate. The blade which is connected to rotor is also going to rotate, and in turn the shaft is going to rotate. That's why we are going to convert this kinetic energy to the mechanical energy. So in the nozzle we are going to convert the thermal energy to the kinetic energy, thermal energy to kinetic energy in nozzle. In turbine, in this blades, we are going to convert kinetic energy to the mechanical energy. Is it clear? So after doing the work, the pressure of the steam remains constant. It will be exit. It will go out. And after doing the work, the velocity is going to decrease, and it is going to decrease. Is it clear? See, this is for the nozzle. So this is for what? Plates. So this is the pressure and velocity diagram. So where we can easily see the variations in pressure and velocity. Is it clear? Any doubts? I hope you understood.